Swayam Prabha. Digital India. Educated India.
Welcome everyone to our online NPTEL course Environmental Chemistry and Microbiology. This course will be taught by Professor Sudha Goel and myself, Professor Anjali Pal. We both are from Civil Engineering Department, IIT Kharagpur. We have divided this course into two parts. The first part is environmental chemistry, that will be covered by me, and the second part is environmental microbiology, that will be taught by Professor Sudha Goel. This is my fifth module, and in my first module I have discussed about the acids, bases and salts. In the second module I have discussed about the chemical equilibrium. In the third module I have discussed about the chemical kinetics. In the fourth module I have talked about the catalysts, and in this fifth module I will discuss about the chlorine chemistry and disinfection. So, I started it in lecture number 23rd, this is 24th lecture, this is part B. In this lecture I will cover the reaction of chlorine with ammonia, reaction of chlorine with other materials, breakpoint chlorination, chlorine demand, chlorine dioxide as a disinfectant, ozone as a disinfectant. I have already told you that the chlorine is a very good and widespread, widely applied disinfecting agent, and I already told you that history, how it is slowly how it is started, how it is developed, and also I discussed about the chemistry of the chlorine. How it is forming the hypochlorous acid, how it is forming the hypochlorites. Now, I will show you the reactions of chlorine with other things which is present naturally present in water. So, you know that I already told you in nitrogen cycle that ammonia is produced from the degradation of organic matter, nitrogen containing organic matter. So, for example, protein molecules like that. So, ammonium ion present in water remains in equilibrium with ammonia and hydrogen plus, that also I have discussed. Now, how it is reacting? NH3 reacts with chlorine or HOCl to form the chloramines. You can see I have shown you the reactions here. The chloramines are called combined chlorine residuals. The chlorine HOCl and OCl minus, that means hypochlorites, hypochlorous acid and chlorine, all these three things are called free chlorine or free chlorine residuals. But the chloramines which are produced by the reaction of ammonia with HOCl or chlorine, that is called the combined chlorine residuals. Okay. Mono and dichloramines have good, they are also having good disinfecting property, but not that as good as the free chlorine residuals. They are not as good, but still they have the disinfecting power. Formation of chloramines are also pH dependent. So, pH has a major role here. You have seen that in chlorine chemistry, and also here also you will see that it has a great role. Higher amount of dichloramine is produced at lower pH. Okay. So, what is the reaction? This is the NH3 plus HOCl, it is giving monochloroamine. Why monochloro? Mono means one, so one chlorine is there. So, monochloroamine, and here further reaction it gives the dichloro, two chlorine atoms are there. So, dichloramine, and then trichloramine, this is a very toxic substance, okay, trichloramine, mainly these two are formed. Now, chloramines get decomposed. So, if you increase, you know, chlorine is a very good oxidizing agent also. Okay. So, chlorine is a very good oxidizing agent, you have seen that. And then chlorine, if you increase the dose of chlorine, then what will happen? These chloramines also will be oxidized. Okay. It will be oxidized. You see here minus 3 to 0, minus 3 to 0. So, it is oxidized, and then dichloramines also minus 3 to here plus 4 state. So, it is oxidized. Okay. So, it occurs at a higher dose of chlorine. If you increase the dose concentration of chlorine, then it will happen. Reactions of chlorine with ammonia present in water, this continuation. What is this? The rate of reaction between ammonia and HCl is pH and temperature dependent. Okay, that I told you. The reaction rate is most rapid at pH 8.3 and decreases as the pH is increased or decreased. So, at a certain pH the rate is maximum, means it is fast, very fast. Okay. But if you increase the pH or decrease the pH, it will become slower. Now, chlorine, HOCl and OCl minus are called free chlorine residuals. I told this thing. This is the reason why free chlorine residual and combined chlorine residual coexist after certain contact period, say 10 minute or 20 minute. Okay. So, if you allow the chlorine to react for some time, and if there is the ammonia present in it, which is very common, okay, then what you will see? You will see that some chloramines have been formed, and also some free chlorines are there. So, it is basically a mixture of all those things. Okay. Now, so there are other reactions also can happen after this stage. So, breakpoint chlorination I will tell you later, but here you see the chlorine is an oxidizing agent. So, ammonia is oxidized to nitrogen by chlorine, ammonia is oxidized by chlorine to nitrate even, this is the highest oxidation state. So, chlorine here is acting as the oxidizing agent, and these are also produced at higher concentration of chlorine. And breakpoint chlorination, what is breakpoint chlorination? I will tell you later after showing the curve. While the free chlorine residuals are quickly, what is the property of free chlorine residual and combined chlorine residual? One property is that free chlorine residuals are better disinfecting agent, but combined chlorine residuals are also have the power of disinfecting power, but it is weaker compared to the free chlorine residuals. But one advantage of this is there, that free chlorine residuals are quickly dissipated in the distribution system. Okay. The chloramines are stable, the chloramines can stay for long period. So, when you disinfect in some place, you do the treatment, the disinfection you do, and then you have to transport the water from that place to some other place. Okay. Then during the passage, you have to protect the water. So, if the chloramines are present there, then it can protect the water during transport. This is the advantage of the chloramines. Sometimes that is why sometimes to protect the water from outside, ammonia is also added little amount. Okay. So, chloramines are, in that sense it is good, it can protect during transport also, it is long lasting. Okay. Transport over long distance, it is protecting. Okay. At lower pH, some trichloramines may be formed, this compound is toxic. So, we should not allow the during disinfection, we should not allow it to be formed. Okay. We should maintain the condition such a way that these things are not formed. Now, so not only the ammonia, but also other things may be present in the water. What are they and how they react with the chlorine, that is also important. Chlorine and HOCl is a strong oxidizing agent, and it reacts and combines with many other different kinds of compounds, and they are called the products are called disinfection byproduct, DBP, disinfection byproduct. Many reactions, some of the reactions are fast, some of the reactions are slow. So, disinfection, now if so many reactions are going on, then it becomes complicated, right. Now, what are those reactions? the and so chlorine, we are using chlorine for disinfection, but chlorine is consumed by some other materials for some other doing some other reactions. So, this is the demand. Unless the demand is met, we will not get the free chlorine to kill the bacteria. Okay. So, those compound first their demand should be met, after that we will get the chlorine, okay, for disinfection. So, what are those compounds? The generated chlorinated compounds create health hazard, that also possible. So, what are the compounds produced during the reaction of chlorine and chlorine with something else? So, they are producing something. So, those may be toxic also. Okay. So, we have to consider all those things. Say for example, in groundwater you know that H2S is present or some sulphide salts are present because water is leaching through the some sulphide bearing rocks. Okay. So, they can react to like this. So, you see H2S gas can react, okay, with chlorine to form HCl and sulphur. Okay. And then there may be some double bond, some compounds containing double bond, unsaturated compounds. Okay. So, addition reaction, we know that in a double bond the something can be added. So, HOCl can be added in the double bond. Okay. So, forming this compound. Okay. And now bromide, you know sea water can contain bromide. So, many places bromide concentration may be there in water. So, when you disinfect that type of water, then HOBr is formed, hypobromous acid. Now, HOBr, you know that HOBr also is good disinfecting agent, but it contains bromine, that is bromine is not a very good substance. So, HOBr, you know, in many countries actually the we have shown the chlorine based disinfectant, but bromine based disinfectant also are used. In some countries I have seen in the swimming pools, you know, swimming pools HOBr is used. They have disinfecting property, but at the same time bromine is there. So, we are not very confident about it. Now, phenols, many water may contain phenolic compounds or phenols. Okay. So, for them chlorine, you know, you can adapt to in the benzene ring. In the phenols there is a benzene ring. So, in the benzene ring chlorine can replace the hydrogen atoms and it can form the chlorophenols. It is dangerously toxic substance and it can have bitter taste also, bad smell also. Okay. So, they are not very good substance for our health. Chlorophenols are formed. This one, organic compounds, you know, humic substances, it is very common in water. Humic substances, they are very stable compounds, but they can react with chlorine to form a special group of compound which are known as THMs. This abbreviated form, that full name is trihalomethane, THM. Okay. THMs are carcinogenic, even though they are produced in very low concentration, say for example ppm level or ppb level, but still if we drink that water continuously, then at least some amount is going within us. So, that produces cancer. So, that is also not, it is not known long time back, but now we know that this type of compounds, you know that what is THM, why this name has come. You see that all the compounds, it is chloroform CHCl3, it is bromoform CHBr3, it is the dibromochloroform or it is the monobromo chloroform. Okay. So, here you see everywhere you see 3 halogen atoms are there, 3 chlorine atoms, 3 bromine atoms, 2 bromine, 1 chlorine, 2 chlorine, 1 bromine. So, it is a derivative actually. If you think about methane, which is CH4, 3 hydrogens are replaced by 3 halogens, that is why tri means 3, halo methane, THM. Okay. Very important group of compound nowadays. And we should not allow these types of compounds to be formed in our drinking water system. Now, what is demand? I told you just now that chlorine demand is chlorine applied, how much chlorine we have applied and how much chlorine is still there. if you subtract residual chlorine from chlorine applied, then then you will get the chlorine demand, that is the demand. So, demand should be made first, okay. After that you will get the free chlorine, before that you will not get, because it is consumed. Okay. Now, this very important curve, breakpoint chlorination curve and chlorine demand. So, this is actually you see here it is the residual chlorine. Experimentally this curve we can get experimentally. Okay. This is the residual chlorine and here it is the chlorine dose, this is applied chlorine dose. Okay. So, we are varying the chlorine concentration and then we are measuring, we are keeping for some contact time, say 15 minutes, 20 minutes. So, we take the sample, then we same sample but different containers, same volume we take, and then we apply the chlorine there at different doses. Okay. We keep it for some time, that is contact time, and after that we measure the residual chlorine, how much is present, and then we plot it against the dose, applied dose, we plot the residual chlorine. Now, if it is distilled water, there is no demand, then whatever chlorine we apply, it will remain as residual chlorine, then we will get this type of curve. Okay. This is the chlorine applied curve, or distilled water, if we do the experiment, it will get this type of curve. But if it is a normal sample water, then there is ammonia. So, basically ammonia is present unless it is some typical waste water. So, in that case we will get this type of curve, this is the nature of the curve. So, why it is increasing first, then decreasing, then again increasing. So, this part will tell you, this the whole part is combined residual, chlorine residual, this is the formation of combined chlorine residual, this is the means this is the chloramine formation, this is the chloramine destruction. So, I told you that chloramines also can react with chlorine at higher dose. So, chloramine destruction, and then everything is destroyed, and then here demand is made, and then this point, this minima is called the break point. Okay. And then after that, when you increase the dose, at an increased dose, you will get the free chlorine residuals. Okay. And this is, you see, the parallel to this line. Okay. Now, you have to apply at least up to this point, the dose, then everything will go, and then little bit extra there, so that some free chlorine residuals are there in the water, which will take care of the killing of the microorganism, that means the disinfection. Okay. So, that is the and you can see here, this is the mole ratio of chlorine is to ammonia nitrogen. So, at different ratio, different things, you see here it is 1.5 here, and then at lower dose it is like this. So, ammonia concentration also may vary, na? That is why it is done here. Okay. So, this we can do experimentally in the laboratory, and then for a particular sample we do not know how much chlorine we should apply, because if we add too much chlorine, that is also not good. Why it is not good? Because chlorine also not good for health. If we add too much chlorine, sometimes we can see in the tap water, we can see that chlorine smell is coming. So, that means they have added chlorine in a larger quantity, which is not required even. Okay. So, that is not good. So, how to know? How to know how much chlorine we should add for a particular sample water? So, we have to do some experiment, otherwise how will you know? So, this is the breakpoint chlorination curve and chlorine demand. We have to know this thing, then we can apply the proper dose. We can use the chlorine, what are the different types of chlorine we can use? Chlorine, we can use chlorine gas, we can use chlorine water, we can use hypochlorite, we can use bleaching powder also hypochlorite, CaOClCl. So, this is also a source of hypochlorite. So, all those things we can apply, but how much a dose we should apply, that we have to know, right. So, how will you know? This way we can know. And also the contact time, it is when we do the experiment, it is always better to measure the contact time should be fixed. for one sample for one sample there are several containers I have taken na. So, we have to maintain the contact time, if because with contact time the ratio all those things reaction is varying. So, we have to maintain that contact time. Now, reaction of chlorine with other impurities. Okay, how can we remove THM? I told you that THM formation is very dangerous for us, THMs are dangerous. So, if we want to protect our water from the THM, then what we will do? We can do two things, there are two options. One thing is pre-chlorination, another thing is post-chlorination. What is pre-chlorination? Pre-chlorination is treatment with chlorination or treatment with chlorine chlorination is carried out before filtration. Means first we do the chlorination, then we filter the water. Why filtering? Because through filtering we can remove the THM, that formed THM. Okay. So, this is called pre-chlorination. And what is post-chlorination? Chlorination is done after filtration. First we remove the organic materials, then we do the chlorination. Both way it is possible. In one case we do the chlorination before filtration, another case we do chlorination after filtration, after removing the organic matter. Okay. But there is some advantage, disadvantage. What is that? If we do chlorination first, then all the organic matters are there, so we need more chlorine, isn't it? We need more chlorine, and then we can remove the formed products through filtration. If we do filtration first, then we do the chlorination, then less chlorine is required. Okay. So, in the first case the cost will be more, because more chlorine is required. Okay. And what about the quality? Which quality is better and why? This is also important. Think about it. Okay. Which quality will be better, from pre-chlorination or from post-chlorination? Think about it. Okay. Now, disinfection, you know, two things are important. One thing is how much disinfectant I am using and how much time I am keeping. Okay. So, for example, I used to go to restaurant that time, long time back, with Geolin bottle. Say for example, they give me one glass of water. I am very thirsty, I want to drink it very as soon as possible, means I am very thirsty. Then what I will do? We will add more drops, say for example 5 drops. I will keep for little time, okay, maybe 5 minutes is enough, and then I will drink. But if I am not that thirsty, I may not use 5 drops, I may use 2 drops, and then I can keep it for longer period of time, say for example 10 minutes, then I can drink. So, contact time is important and also the concentration, and kill is proportional to concentration to the power n into T. Okay. Disinfection is carried out to kill. What is the purpose? It is the purpose, what is the purpose? To kill the harmful microorganism, okay, but it does not give us sterile water, which is needed for the operation theatres and for other purposes, sterile water. So, it is not killing all types of bacteria, it is only killing the pathogenic bacteria. This is true when disinfection is done with chlorine or chlorine dioxide. This is also another disinfectant, chlorine dioxide, or ozone is another disinfectant. These are used in the developed countries, ozone, and this is not much attempted, maybe some research has to be done maybe. But chlorine is most widely used. In our country also we are using chlorine. Now, and that is with long contact time. This I already explained to you that contact time and concentration we can vary depending on our what we want actually. Okay. Then pH and temperature also has great influence, that we have already discussed pH and temperature, how it is affecting the disinfection, and lower pH is more effective for disinfection, lower pH, at lower pH, but we usually do it at around 7 to 8. Okay. And free chlorine residual is more effective compared to combined chlorine residual. I already explained, but it is more it is required for transport, during transport combined chlorine residual is important because it can protect the water, because during transport there may be some contamination. So, that it can protect, that combined chlorine residual can take care of it. Now, disinfection with chlorine dioxide, ClO2. Chlorine dioxide is a very good disinfectant at higher pH condition. Okay. So, these are the properties, that is these are the observations. It is as effective as HCl is a very good disinfectant. I told you among the 3 free chlorine residual, this is the most effective. So, chlorine dioxide is also very effective and can act at high pH condition. It is an unstable gas. This is a gas, this is not solid like CaOCl or CaOCl twice or NaOCl, these are all solids we can use. Solid is better, you can carry from one place to another place, but if it is liquid, it is still it is okay, but if it is a gas you cannot carry it, right. So, but this is a disadvantage for chlorine dioxide. Okay. It is an unstable gas and it has to be produced on the site itself. Where you want to disinfect, you have to produce there only. Okay. This is a great disadvantage. And how you can produce it? This is chlorine, it is an oxidizing agent. So, NaClO2, you can see what is the oxidation state. This is the +3 state. So, +3 state to +4 state. So, this is oxidation. Oxidation means chlorine is oxidizing. So, it is done by mixing a solution of sodium chloride NaClO2 with strong chlorine solution. This way it is produced, it is a gas. At pH below 4, the production of ClO2 is higher. Okay. It is costlier compared to chlorine or hypochlorite. The chemistry of ClO2 is not explored much. Still it is under means it is not, we are not very confident about this material till now. The advantage is that it does not react with NH3 to produce chloramine. Chloramine is not produced, this is advantage. Another thing you can tell that if chloramine is not produced, then transport is it is not protected. It does not react with natural organics, this is good because it does not produce THMs, because natural organic material, that is humic substances, it does not react, and so it is not producing THM. ClO2, in case of chlorine you have seen that chlorophenols are formed, but here you see that ClO2 can destroy phenolic compounds. Okay. So, this is a good thing, it can destroy. Okay. So, there are advantages and disadvantages also. Now, disinfection with ozone, ozone is also widely used nowadays in advanced countries. It is very strong, actually strong disinfectant, even at low concentration it acts nicely. High cost, because ozone production is very difficult. Okay. And the equipment which is required for ozone production is to be maintained on the site itself. So, again problem. It does not produce long lasting residual, these are advantage. Chloramines, it does not produce chloramines. Advantage, sometimes are disadvantage, means chloramines has to be added sometimes. Actually it is advantage, you can disadvantage you can tell. Okay. Another advantage for ozone is that halogenated organic compounds are produced during disinfection. No halogenated organic compounds are produced, because halogen is not there, how halogenated compounds will be produced. So, it is advantage, right. A disadvantage is that ozone reacts with but the ozone is stronger. So, it can react with natural humic substances. Natural humic substances to produce organic compounds which are more susceptible to biodegradation. Maybe THMs are not produced, but some compounds are produced which are susceptible to biodegradation compared to the natural humic substances. Then what will happen? It causes growth, because some biodegradable substances when present, so bacteria will grow, and when bacteria will grow, so in the distribution system, so water quality will be reduced, is not it. So, that is a disadvantage with this ozone. Beyond disinfection, ozone has some other effects. It can remove the odor, it can oxidize iron or Mn2 plus, iron 2 plus or Mn2 plus, which sometimes is present in many water, okay, and it when it is oxidized, it can be precipitated also as oxide. It can destroy organic compounds that causes odor and taste. So, water quality will be better when it is all these types of compounds are is destroyed. Okay. So, ozone is also a good possibility, but costly. As a reference, I can tell Swayam, the same book you can read, very nicely written. And as conclusion, I can tell for this lecture that disinfection is a very important water treatment procedure to kill the pathogenic bacteria. Chlorine is widely used for disinfection purpose. Chlorine produces hypochlorous acid and hypochlorite ion, which are known as free chlorine residuals. During chlorination, chlorine reacts with other impurities present in water. It reacts with ammonia present in water to produce chloramines, which are also disinfectants and known as combined chlorine residuals. They are weaker but long lasting. Breakpoint chlorination and chlorine demand is explained. Application of chlorine dioxide and ozone as disinfectant is also explained. Okay. So, thank you very much.